For my review video for Math 3283W, I'll be talking about ordered fields. An ordered field is a set on which it's closed upon multiplication, addition, subtraction, and division. So if you do any of those operations on any element of the set, then it will result in an element that is still in the set. An ordered field is a field that has an ordering. Some examples of ordered fields include the rational numbers, the real numbers, and the set of rational functions. So just some examples to show this is on the rational numbers, you would have numbers like 1 and 2. And if you have 1 plus 2, that equals 3, which is in the rational numbers. 1 minus 2, negative 1, which is in the rational numbers. 1, and etc. If you have an ordered field to determine the ordering, like in this example here, you would subtract one of them from the other. So you would have, for example, 1 minus 2 equals negative 1, which is less than 0. So you know that 2 is greater than 1. So for rational functions, a rational function q of x is equal to a function f of x over a function g of x. So one example of a rational function, if we go up here, is x plus 1 over x minus 1, because you have two functions that are over each other. And this function is defined at all points except for x equals 1. Because if you have x equals 1, then you get 0 in the denominator. So to determine the ordering of rational functions, you do it similarly to the way that you determine the ordering of other ordered fields. So you can take two functions, let's just say f of x equals x plus 1 over x minus 1, and g of x equals x plus 1 over x minus 2. And you can subtract them. So for example, f of x minus g of x equals x plus 1 over x minus 1 minus x plus 1, x minus 2. So then to subtract, you have to get equal numerators or equal denominators. And you have x plus 1 times x minus 2, x minus 1, x minus 2, minus x plus 1, x minus 1, all that over x minus 1, x minus 2. And then you have to expand them both out. Minus 2x. Minus 2.
My grandpa gets definitely long in Jersey. I wouldn't call him. That's so cute.
Then subtract them, so you see these cancel, and so you have x minus 2x minus x minus 1 minus 2 over x minus 1, x minus 2. And simplifying, you see that you get a negative x out in front, so this would be negative 2x minus 3, x minus 1, x minus 2, which is, and because the function is negative, you would have that f of x, if we go here, f of x is less than g of x.